Okay, so in this example, we're going to be talking about simplifying rational expressions. So we'll do a couple of examples here. So here is our first example. Notice that we do have a rational expression. So when you're trying to simplify rational expressions, you want to first try and factor both the numerator and denominator. By doing this, you may have some factors that you can cancel out, and that will help in the simplification process, right? So starting on my numerator, it looks like I can pull out a 3x. So just rewriting the numerator, we're going to have 3x. And then in parentheses, we're going to have x minus 1. Okay? Now working on the denominator, we can also pull out a 3x. So we're going to get 3x. And then in parentheses, we're going to have x squared. Okay, minus 2. All right, and then plus 1. All right. So at this point, we can see that, well, 3x and 3x, that's going to cancel out. All right? Now, let's look at our denominator here. We can actually factor this even further, right? So let's go ahead and do that. Just rewriting this, we're going to have on the numerator x minus 1. And then factoring this further, we get x minus 1 times x minus 1. All right? Now from here, we can see that, well, x minus 1 and x minus 1 are going to cancel. So we're left here with 1 over x minus 1. This is going to be your final simplified answer. Now it's important when you simplify these rational expressions, you include any numbers that will make the expression undefined. So for example, if you go back, right, we know that we cannot have division by 0. So notice here how I crossed out this 3x. If I were to plug a 0 into here, that would make my whole denominator 0, okay? So in that case, we know that x cannot be equal to 0. And we also know at this point, look, if I plug a 1 in here, 1 minus 1 is 0, right? And that will make my denominator 0 again. Again, we cannot have division by 0 because then it will be undefined. So x cannot be equal to 0, and x also cannot be equal to 1. Okay, so we want to include that as well. All right, and this one is now complete. All right, let's try another example. Okay, so here's our next example. So same thing. Let's see if we can go ahead and factor the numerator and denominator. Now looking at the numerator, it looks like I can pull out a 4. So let's go ahead and do that. So I'll have 4, and then in parentheses I'll have a squared minus 6a, okay, and then plus 5. And then working on the denominator, you can just go ahead and rewrite it as it is. A squared minus 11a plus 24. Okay. Now we want to see if we can factor, okay, further using the AC method. Because notice I do have a quadratic and a quadratic. So let's try to factor this using the AC method. Okay. So using a times c, let's work on the numerator. So a times c. So a is going to be 1. C is going to be 5. When I multiply the two, I get 5. And we say to ourselves, what two numbers when we multiply will give us 5, but add up to our b, which is negative 6. Again, this is going back to ax squared plus bx plus c. This is a quadratic in standard form. Okay, so we should be familiar with this. So again, two numbers when they multiply will give me 5, but add up to negative 6. Okay, and that's going to be negative 5 and negative 1. So we can go ahead and factor this the following way. We can say 4, and then in parentheses, a minus 1 times a minus 5. Okay? Let's do the same thing on the denominator. So working on the denominator, we know that a is 1, c is 24. So when I multiply those two numbers, I now get 24. So what two numbers when I multiply will give me 24, but add up to negative 11? Well, that's going to be negative 8 and negative 3, right? So rewriting this, we get a minus 8 times a minus 3. Okay? And notice none of our factors cancel out, so this here is going to be our final answer. Okay? Now, let's go ahead and just include those values that will make this expression undefined, right? So if a is 8, so I'll make it 0, so the denominator will be 0, will be undefined. So we can say here a cannot be equal to 8, okay? It also cannot be equal to 3, right? Because again, it will make it 0. Okay, so this here is your final answer. All right, so that's simplifying rational expressions.